Hello. How you guys all doing? My name is Taokor, and I am one of the co-founders for Project Owl or Owl Integrations. And I deal with anything data related. So today I'll be talking about the version 3 that we recently released in probably around beginning of March, middle of March. And what we're doing with the data is we want to be able to see what kind of insights we can extract from the data. So before we get into the code and I'll talk about the data, I would like to talk about what's new in version 3. So the new features that comes with version 3 is one of the main things. Well, actually, so one of the main things is the send commands from a network, to a network. So from our data management system or from any type of operator, they can send commands to the network. So this is actually a big step because this is going to be building a foundation for two-way communications. So not only our network from our ducks can send data up to the cloud, but also we can get some commands from the cloud going into a network. So that's very exciting news. In addition, we have a bloom filter implementation. A bloom filter is a hashing algorithm. And previously the problem it solves is that previously what happens is our network is an ad hoc mesh network. So data hops from one device to another. And what happens is when it hops to a different device, we collect that device ID. And then as it keeps on hopping and hopping, we're collecting more data, collecting more IDs. And eventually the packet gets so heavy with all the device IDs. So that wasn't very feasible, especially when we're trying to scale our network. So with the bloom filter, it uses probability and statistics to figure out if it has seen this message. And yeah, so this is a probability algorithm, and we also wrote an article talking about the bloom filter. I can share it right now if you want to get more details about it. Yep, shared. So that's a little article going over what the bloom filter actually is. And one of the main things that I'm very excited about is the unique event types. Before, when we send some data, we used to just send, hey, this is some data, but now for version 3, we organize the data to certain event types. Meaning, when we deploy the ducks, there's events such as sensor data, we collect health data, and we collect some GPS data, but it's all under one event type, meaning a sensor or something. But now for version 3, we kind of cleaned it up a little bit, organized it, and now if it's a temperature and pressure reading sensor, we have a specific event type for that. If it's a GPS reading, we have a specific event type for that. And if it's a infrared sensor or health sensor, we also have a specific event type for that. So this actually organizes our data a lot better, and especially when we get in cloud and when we try to create some sort of even flow, a nice flow going into our pipeline for data extraction, it'll be a lot smoother. So coming from a data side, I'm very excited for that part because before when I was analyzing data and it was all under in one category sensor, it was very hard to figure out and very tedious to try to separate the data. But now with this organization structure, it's a lot more simpler. All right. So we also recently open sourced some data. So in our office in Brooklyn, Greenpoint, Brooklyn, we actually deployed a 4-duck network, 3 mama ducks and 1 papa duck. And so these 3 mom ducks, 2 of them are very special because they have sensor incorporated in them. One of them has a BMP 180, which is a temperature and pressure reading, and the other one is infrared reading, which senses if someone passes by, right? It's a little light sensor, so it can detect if any light changes occurs. So once a light change occurs, it sends an alert. So those are two sensors, and then we have a regular mama duck doing health sensor, so it sends some health data, so we can see how well our network is working and to figure out if we are having any issues within the network. And the fourth duck is the papa duck. So the papa duck is the gateway duck that collects all the data within the network and push it up online to the cloud. So yeah, that being said, let's get to it. So for this live coding session, I'll be using Jupyter Notebook, and we have these data open source. We recently open sourced them. We have also a description of what the text is, what the data is, and some sort of specification of what each column represents. So I can also share that link with you guys. Just give me a second while I find the link. But yeah. General. Okay, awesome. All right, so yeah, this is the specification of what the data represents, and then we have this beautiful, sweet data. So right now it's a little, so this is CSV, so right now it looks a little complicated, but here what we're going to do is we're going to install it using Python. I myself is a Pythonista, I believe that's the proper term these days. So yeah, so we'll be working in Jupyter Notebook and we can get started. I will call this V3 live stream analytics. And yeah, so this, and if during this live stream, if you have any questions, feel free to ask. And if you have any questions about the data, you feel free to ask, and I can try my best to answer it. So yeah, before I continue, we do have an open source community. If you see the live stream, there's a QR code. If you scan it, you'll be sent to our Slack, so feel free to join that as well. All right, so as usual, let's import pandas. I'll be visualizing the data as well, so I'll import matplotlib, plot. And as always, I like to import NumPy. Imports, okay, so now pd.read, we can call it df equals pd.read csv, lowercase c, copy this, do some copy and pasting. Let's see what this does. df.head. Okay, awesome. So we read in the data, and yeah, based on this description over here, it basically walks through what each of these columns are. So we have the Papa ID. In this case, it's named OwlHQ, and that is the ID that we registered our IoT device to be able to extract the data and push up to the cloud. So depending on if you have your own network and if you want to register your own IoT device, that'll be the actual device ID that's getting the data. Then we have the payload. The payload is actually the information that's being relayed within the network. And within the payload, they have more payloads as well too. And we'll go into that later on. This is where the meat of the data is created at. That's actually the time frame, the timestamp where the data was actually inputted in a database. So not necessarily when the message was created, but when the message was reached in the database. And this is what I was talking about, the event type. So right here, we can take a little glimpse, GPS, BMP, health. Just by being able to categorize these event types into these categories, it just makes the whole data process analyzing so much better. All right, so let's see. So first, let's do the easiest one first, event type. df.event type dot unique. So this will give me the unique types of event types. I've been getting really good at, forcing myself to document this as well too. So I'm gonna do a little documentation as well. And mark down how many, what are different types. Hey Timo, how you doing? What are the different types of event type in our data? So in this case, in our office, we have these many. What are different types? And actually, I should also print out how many unique ones we have. Event type. I think the command is unique. So yeah, so there's 8 different types of event types, and these are the 8 ones. So, and also event, let's see how many of each we have. Let's try this. Value counts. I believe that's the command. Okay, awesome, yeah. So within our data that we open sourced, there are these many types of specific ones, and if we want to plot it, I think plotting, visualizing it makes a lot more different. Actually, let me put event types is equal to, oh no, this is Python, we gotta do the underscore. Event types dot, I think that's, okay, cool. So now we have event types dot plots. Maybe it's bar. So it's a plot, maybe be a line graph. So I think it's kind equals bar. All right, cool. So yeah, let's clean this up a little bit. plt.title. Number of messages per event type. PLT to title. We'll add a X and Y label. X label is event types, and PLT.Y label is number of messages. Awesome. So I think for this stream, I'm just gonna do these simple graphs, but I'm also going to work on cleaning them up and making it nice. I've learned from Timo, our designer, that, you know, he inspired me to make all my stuff simple and clean. But for now, I think this is suffice, and it shows that we get a lot more health message compared to the others. And that actually makes sense, because health messages, no matter which duck you use or which sensor you attach, our firmware that we configured specifically for our office is that each duck will send some health data, so that we kind of get an understanding of how our network health is doing. So if we have 4 ducks, then we have like 4 times that amount of health messages popping up. Okay. So yeah, and then I will label this event type. And we will see how it's so much easier now that we have these specific event types. But yeah, now what I'm going to do is basically filter out, extract based on the event type. So before we weren't able to do it. Well, we did like, sensor, and then have to figure out how to go deep into the code and manually pull out the temperature sensors, the BMP sensors, the infrared sensors. But now it's just a lot more convenient. Okay. So let's see, what do we want to do next? So before we go ahead, so let's see what our shape is. So the data that we open source, we have 145,000 data points and 4 columns. So, okay, and then based on this, what's our time frame? So df created at .min. Okay, we can just do like a quick print statement. The data ranges from, God, I forgot the quotes. Ranges from this to df created at .max time. Time ranges from this to that. This extra column here, extra quote. Okay. So we have this. The time ranges from, it's from March 1st to May 17th, and that was actually the date we published our data when we open source our data. All right, so within this time frame, we have 145,000 data points, so some interesting stuff. Event types, okay, so now yeah, let's go into the payload. So going into the payload, so as you can see, there's more data within the payload, so we'll have to extract each data point here. And there's a lot more data to talk about here, which is very exciting, well, for me. So let's see, df payload. Okay, so then within the payload, it's like a JSON of all the other information, so we'll just have to extract it. So how do I do that? Okay. Actually, no, I think I know how to do this. Okay, actually, before we continue on, so this is supposed to be a JSON, right? However, if you can see this quotes here, the pandas data frame assumed its property as a string, so we actually have to convert this into a JSON. I actually ran into this problem when I did like version 1 and version 2. So that's why it kind of hit me when I did it, and I was supposed to. So there was a literal Stack Overflow. I can't go anywhere without Stack Overflow. Yeah, right here. So this Python function converts a string into a specific object. In this case, will be a JSON. So from scc import literal eval. So I might have to read in the data again. How do I do this? I have to I think. Let me just check pandas. Read CSV. No, actually. Oh, there you go. I think it's converters. How do I do this? Command find converters. So this dictionary. Okay, so it has to be a dictionary. So I need to convert payload, and I am going to pass in this, I believe. So actually, before I say, let me see if it worked. Okay, forgot to run that cell. Okay, cool. Okay, looks good. Working. Okay, so now you see how it changed. So by adding these converters in the pandas VTSV, I was able to change their object type. Right? Before payload was a string, and then I basically took out the string. Basically take out the quotes, actually. All right, so now we took out the quotes, and this is JSON. So now there's even more data. So more meat and potatoes here. So here we have the device ID. The device ID is the ID that is the ID of the message of the duck that the message came from. In this case, we have a duck named duck BMP1, and the duck BMP1 send this message. Okay. So we have, this is a unique message ID, and then it also has its payload. And if we look at the first one was a GPS type. So of course we'll get some latitude and longitude, and some altitude as well too. We have the path, the hops, and so path, we talked about I briefly mentioned about the bloom filter. So this path will be empty temporarily because now that we implement a bloom filter, we don't need to add in the device ID into the path. What we'll do is the bloom filter will be able to use probability to determine if a duck's seen a message. So that's why right now we don't have it empty, but I think we'll be adding some content here later on for other purposes. Hops, these are how many hops the message went through to reach the to reach the cloud. In this case, the hops is 1, meaning the duck BMP1 sends a message, a hop to the popper duck, and the popper duck push it up to the cloud. So that's why the hops is considered 1. And in our offers is very small, so we can actually check our hops as well too, but I'm assuming that all of our hops will be around 1 because LoRa, it's long range and it works very far. I think the things network, the longest range was like 868 kilometers. But we can figure out, I think, yeah. Yeah, I believe it was like 868 kilometers. That's the longest they were able to send a LoRa packet. But in this case, we're talking about 20 feet by 20 feet. So it doesn't need to travel that far. So that's why I was able to reach that far, without even needing to hop. And the duck type is 2. So based on what the type of the duck is, that's what it is. And I believe mama ducks have type 2. All right, so now we have this, and now what we want to do is actually extract all these elements and add it to our data frame. So PD.to series, I think. Is it 2_series? Oh wait, is it no 2s? Okay. Third time is charm. Let's see. So I'm converting this dictionary, this JSON, dictionary. If I put PD to series, what it does is it converts it into a series where this is the column name and this is the information. Column name and this is the information, right? So I need to do it for all of them. Before I had an index of 0. So that's why I only did 1, but I'm wondering if, okay. Hold on. Actually, that didn't do anything. Let me figure this out. Stack Overflow. Alright, actually, let me do it here so that you guys can see what I'm doing. Convert column of dictionaries into separate columns. Pandas. Oh, okay. So I have to apply PD series, not. Wait. Oh, it's saying not to use it. Create data frames. What's statistics? Oh, statistics is a column. So saying pd.json normalize. Let's see if this works. Oh, that does work. Okay, awesome. So now what we did is we broke down the JSON into each column, and I think I have to merge it to the original one. So df is equal to pd.merge or pd.merge, yeah. I keep on forgetting merge and concatenate what the difference is. Actually, before I set it equal to df, let me see if it works first. No. Let's see. So is it concat? First argument must be iterable of pattern you pass an object type data frame. Oh, it has to be in a list or something. So what did this do? This did not do it. It increased the data points, payload. Pandas, concat. Oh, access, right. I forgot access. Wait, X. So we want to concatenate column-wise. Okay. I keep on forgetting that. Access. This looks good. The payload duckpmp1, duckpmp1, message ID y3qs, y3qs. It's looking good. All right. So we still maintain the same amount of rows, nbjj, nbjj. It's looking good. All right. So now that's gonna be my new data frame. So I'm gonna save. Yep. df.head. Okay, so we don't need this payload column anymore because we already extracted all the information from here into this. So yeah, let's just drop it for now. It's the lowercase one, okay. Lowercase in place equals true. What? Oh, access. I forgot it again. All right, awesome. All right. So that being said, so let's look at, I think the quicker one is hops and duck type. Path will be empty and message ID, device. Okay, we're gonna look at, okay, so going forward, right now, what we can do is look at the device ID. I'm gonna write this down because I forget. How many messages came from each duck. Actually, I'll write device ID, which is a duck, right? Event type, we already looked at event type before. We'll look at, just to clarify, we'll look at the hops. How many hops are, how many unique hops are there? Unique hops. And duck type should be 2, but we can also look at that as well too. It doesn't hurt. Okay. So I'm going to tackle these first. These are, I'm just going to do easy ones quick to get out of the way. Markdown. I think I'll just use the same thing I did before, df duck type the unique. Oh wow, there's actually other ones too. That's interesting. I'm actually not sure what these duck types are. I'm actually glad that I looked at it because usually I don't. The lock df not equal to 2. This one's a string too. I'm not sure why. Okay, that makes sense. This might be something we have to fix, or maybe not. So 1 is coming from PapaDuck. So PapaDuck also has a health packet as well too. So that's coming from the PapaDuck. Now I want to see. So 1 makes sense, but what's 162? Interesting. So this one has hops of 2, and the duck type became 162. We might have to flag this. Kind of curious what the other ones say. Oh, this one hopped 4 times. This one wasn't part of the deployment though. And 6, 2, 10. Yeah, this. So we also do some testing for other deployments as well too. So I'm thinking that these came from the other ones while we're testing. But this is good stuff to know. We can always double check to make sure that it works. Huh. Duck type 98. All right. So there's like 4 instances where the duck types were not what it's supposed to be. That's good to know. We can fix this bug. I'll put a GitHub issue in our open source community. I'm actually glad that we did the duck type because I usually just skip it because I always think it's 2. All right, so I will let people know. So duck types, and then we'll look at hops. Okay, based on these hops, I see that there's more than, oh, this one has 15. All right, because this is Mama Duck. Not part of the network. But anyway, so hops, let's look at this. df hops dot value counts. So 0 hops, that will be the popper duck, meaning there was no hop because the popper duck just sent the information up in the cloud. So there are 2, 4, 3, and 15. Ooh. So let's look at that stuff. df hop, no, df dot log df. Oh, is hops a string? Okay, so some of the hops might be string actually. That actually makes sense. Maybe. Okay. df hops pandas convert column of string into int. Oh yeah, as type int. That makes sense. Okay, and if it's greater than 1, we got a corruption here. So we have some instances of when it's 2. So that's actually great. That makes sense because sometimes, you know, one message doesn't get through, but the message is still out in the air and it still hops when it's in the air. So this is some good stuff. And then now let's look at when it's greater than 2. I'm kind of curious when it's like obscene mounts. So these ducks are not part of the network. I think this is what happened when we were testing it, testing new ones. So that makes sense. There's a little corruption here, and we can look into the corruption and see what we can do to improve it. This is good stuff. My assumptions were wrong, where I thought it'd be 1 or 2 and 0, but then there's 28, 29 instances where it wasn't. I will flag this as well. So, okay, now let's go to Markdown. So that being said, we should take out that device ID. We will be looking at device IDs, or the ducks. So df device ID, is it ID capital I? Yeah. Dot unique. Oh, there's a lot of ones that we've been testing with. So the ones that we've been working with is this one. happen. Oh. So in our office, we do a lot of testing with our ducks. So some of these ducks were probably from when we were testing it, and our network actually picked that up. So we will just extract the ones that are part of the office network, and yep, office ducks. Let's do this. Now df device ID. df.lock device ID if so now I'm going to try to filter out. Is this a command? Okay, yeah. Okay. So the ducks that are on Office, that operates in Office, is these. So I'm just going to use this for now, and we'll be tackling these later on to figure out some certain reasons of why it happened. I'll be working with these. So now maybe if we can even try doing these hops and see how well. Okay. So that makes that's more reasonable. Okay, so now we cleaned up a little bit, just with the ones that we'll be working on. And now how many messages came from each device ID? So that's just a simple group by, or which is even do, yeah, let's just do group by. Group by device ID and do message ID dot count. And we can even plot this actually. Plot kind equals bar. Yeah. Let's add a title here. plt.title number of messages sent by a duck. plt.x label. Just doing my due diligence with the visualization. Oh, they have device ID y label. Number of messages. And then you can add a semicolon to get rid of this little text, or I think you can even just do plt.show. Yeah. Simple stuff. All right, so now we did this. How many unique hops? We did that. How many duct tapes are there? We did that. How many messages came from each device ID? And we did this. Okay. It is 12:50. So before we continue, okay, so I do want to show you the sensor data. So one thing, so these are all sensor data, health duck, IR duck, how many messages the IR duck sends. And this makes sense because this is a motion detection. So if people walk through the office, the sensor detects it and it sends a message right away. So I do want to look into that. So, and this is also the benefit of having event type here. And so let's look at the GPS first. Let's see where the device IDs are. GPS is equal to df dot lock df event type is equal to GPS. Get all the rows, GPS dot head. Okay, cool. So this one has all the latitude, longitude, and altitude as well too. Huh. A lot of tongue twisters right there. All right, so now what we're going to do is extract the latitude and longitude and plot it, and to show you where these device IDs are. GPS, payload, the STR. So I need to extract these lats and longs. Dot splits by space. Okay. 0. So pandas convert column of list into columns. Yeah, that's exactly what I want. Let's see if this works. If you have your control and a C and a V, you're a programmer. Dot to list. Okay, that's what it's doing. And columns, I like to break down the code to see what it does. So this is latitude, longitude, and altitude. Now what we're going to do is pd.data frame. Okay, awesome. So we were able to do that. Now we're gonna GPS. Now we're gonna concatenate with the access, because I remember the access now. So how did I do it though? Okay. Copy. I don't need this anymore. GPS is equal to GPS. and I have the access equals to 1. That did not work out. What happened here? Oh, now it's not working anymore. What happened here? GPS.hen. Ah, already concatenated. That's why. Ah, crap. All right, so let me just redo this. That's fine. And then if we have T, that should be that. So all we have to do is concatenate GPS and T with access equals to 1. No, why is it doing that? Oh, okay. I see the problem. The index. So when you concatenate, I think it concatenates based on index. So when we filtered it out here, the GPS, it still came in with the indexes 0, 11, 24, 34, 43. And then when I did this, when I extracted a latitude and longitude, it created its own index 0, 1, 2, 3, 4, 5, all the way here. So now when I'm trying to concatenate, it's trying to match these indices. And that's why it's not matching correctly. We have 0 and then 1, they're saying, hey, there's no 1 here, but there's a 1 here. So they try to concatenate with that. So what I can do here is reset index here. Reset index. Drop equals to true. Okay. Nice. All right. So this is exactly what we need. Okay. So we have the GPS. So now GPS, latitude, longitude, I spelled longitude wrong. Longitude. Longitude. Might as well just redo this. All right, cool. Not unique. All right. What am I gonna do? So what I need to do is find the location for each duck and plot them. Okay. So now I have to do, before I do this, GPS dot group by device ID, and I'm going to look at latitude and longitude. Did I spelled it right this time? Oh, right. Whoops, forgot that part. So our latitude has this lat semicolon 000, but we don't need that lat part. So we have to extract that out. GPS, we're running a little over. So maybe for the rest of the stream, I'll plot these points, and then I can plan another stream where I'll go over some more data points here. Latitude dot split dot str dot split by semicolon. We don't need the, okay. Oh, I guess this is the same thing we do here. Probably not the most efficient way, but we'll do it just for time being. str GPS the latitude equals to that. Wait, dot as type float. Yeah, I'll just do it. Oh, wait. GPS. Just fixing some type errors. I'm just gonna do this real quick. Oh wait, copy. I'm gonna comment that out. GPS longitude is equal to GPS longitude of 0. No, I don't need that. The as type float. Oh. Now the types should be fine, and I think okay. So I got that. Interesting. Now GPS dot group by longitude dot median okay. Okay, so it seems like these two ducks, duck BMP1 and health duck 1, they were tucked away inside a building, so that's why I guess they couldn't get any GPS reception. And that's kind of like the fallback of using GPS. You know, if it cannot connect to a GPS satellite, it won't get any efficient results. The IR duck is actually attached near a window, so that's why I was able to get some sensor readings, some GPS connections. So I think it's a little past our time, but we can call it stop here and we can continue it later in the next stream. But yeah, so we have the mapping details, and what I'll actually also do is write a blog to basically organize all the data and talk about like each sensor and what they provide. So yeah, thanks for joining. Until then, I'll see you guys next time. Bye.